Namaskar my dear friends. Let us talk about more types of particular integrations. So let us say we have integration of type dx by square root of a square ax square plus bx plus c, or some integration of px plus q by ax square plus bx plus c. So how to solve this kind of questions, right? So we have already seen some 6 formulas for particular type in the last session, like integration of dx by x square minus a square is equal to 1 by 2a log x minus a by x plus a, and so on. So what we'll do is we'll try to convert this kind of forms into some known forms of this kind, okay, by substituting some of the parts, right? So what we'll do is we'll try to understand one of the one by one all the types of integration that we are going to see right now, okay. What are the process of proceeding to convert them into, let's say, a square root of x square plus a square, or square root of x square minus a square, like that. So let's start with each one of the type one by one. So let us say question 1 was type of the integration is dx by ax square plus bx plus c. So how to solve this type of question? So what is our understanding is we have to convert it in terms of one of the known form, let us say something by x square plus, let's say, some k square, or x square minus k square, like that. So what we can do, we can represent ax square plus bx plus c is equal to, let us say I am going to take a common, so I will have x square plus b by ax plus c. Now can we convert this into a square term? So yes, we can do that. We can do that by, let us say, x square plus 2abx plus some constant c, right? So this is how we will be having, or we will have 2xy plus y square. So this will become x plus y ka whole square. So like this we'll try to convert. So our aim is to make sure it comes into a square term. So what we can do, a times we'll have it as x square plus 2ab. So let's say 2 times b by a into x, and plus b square, so I'll have by a square, okay. So this is the thing we got. Let me make it little bigger bracket. So we have now x plus b by a whole square. Now what is the additional term that we have added? So we have added 2 times, so I'll have to divide it by 2, and we have added b by a whole square, so I'll have to subtract that also. So b by a whole square minus it will be there, and then plus c. Now can we write it down as a times, this can be written as x plus, okay, so what we can do is 2 times b by 2a is there, right? So can we make it b by 2a, and then in that case I'll have to subtract b by 2a. Understood? We are actually trying to step in the same fashion, like 2 by 2 we did, so complete b will be considered as b by 2a. So b by 2a square should come, and then b by 2a square should get removed, right? So we will have x plus b by 2a whole square plus we have c minus b by 2a whole square. So this is another constant, right? Now this can be written as, let's say, some square minus some k square. So this is how we are going to convert it as, we will have to put x plus b by 2a is equal to, let us say, t, and this is how we are going to get dx is equal to dt, and in this integration we will have to substitute this value to get the particular formula, and this particular integration will be reduced in the form of, let us say, dx by, or dt by some t square plus some k square, where k square is nothing but c minus 2a ka whole square, or otherwise it can be minus k square. If c is smaller, this is bigger, then it will be minus. So like that you can understand. Let us take another type. We'll take questions based on this, but you have to understand the topics, or understand the concepts. Let's take another type, that I can take it as question number 2 type. So question number 2 type will be, let us say integration of dx by square root of ax square plus bx plus c. So same way just now we did as ax square plus bx plus c is equal to a took common, so x square plus b by ax plus like c. So same way you can proceed, just now we studied in first one. Okay, so there is nothing like a difference in this. A square root of a square plus k square also we have the formula, so you can proceed in the previous formula that we just now studied. Let's take another question. Question number 3, it will be of the form of, let us say, px plus q by ax square plus bx plus c, okay, dx. So in this kind of formulas, what we can do is, one of the thing that you have to understand is all these p, q, a, b, c all are constants. So let me write it for you so that you can understand. P, q, a, b, c are constants. Understood? So how to solve this kind of question is, our aim is to replace this px plus q in terms of differentiation of the denominator. Okay, so it will become px plus q can be written as some constant a times d by dx of ax square plus bx plus c, okay, plus some another constant b. So if you replace this, we are going to get how much? A times this will become how much? 2ax plus b plus some constant b. Now if you try to solve another time, it will become px plus q is going to be how much? Let's say x term and constant terms will take out, so 2a into x plus it will become ba plus b. So as you can see, both the side, this term is constant, this term is constant, then this term is with x, this term is with x. So we can see by equating we are going to get p is equal to 2aa and q is equal to ba plus capital B. So this is how we are going to replace my p and q with these two terms, and this is how we can solve it very easily. What would be the other type? There is a possibility that we can get a square root of this. So let's say question number 4. Question number 4 can be of the type of integration of px plus q divided by a square root of ax square plus bx plus c dx. So same way you have to proceed as same as question number 3 that just now we did. Okay, alright, so let me give you a question so that you can have an understanding, and we will solve more problems in our next session. So first problem is, let me give you one problem here. Question is integration of dx by x square minus 16. So there are a lot of particular solutions type or particular type like integrations. So we'll solve one by one and then we'll see this kind of questions. Okay, so what can we do? Can we write down in terms of dx by x square minus 4 square? So it is looking like integration of dx by x square minus a square, and you know already the formula for this is, what was that formula? The formula can be 1 by 2a log of x minus a by x plus a plus some constant c. So similar to that I can write it down here, 1 by 2a, so 2 times a, that is 2 times 4 into log of x minus 4 by x plus 4. So this is very simple question, plus some constant c. Let's take another question so that you can have a complete understanding and you can try it by yourself. So let us say question number 2, integration of dx by x square plus let us say 25. So what will happen? It is of the form of, you can see very easily that it looks like dx by integration of dx by x square plus a square. Alright. So what was the formula for this? We know that it was 1 by a tan inverse of x by a plus some constant c. Okay. So in that case, what we can do here is we can write it down in terms of integration of dx by x square plus 5 square. Okay, and in this way we can write it down 1 by a square. So a is 5, so I can write it down 5 into tan inverse of x by 5 plus some constant c. So this is the solution. There is a possibility that you can get it something like this. Question number 3, let us say integration of dx by let's say x square minus 3. So 3 is not a standard, like a square root or a square of some variable. So what we can do is we can directly write it down integration of dx by x square minus root 3 ka whole square, root 3 square. So this is how it is looking like. Question number 1 just now we saw. So this can be very easily written as 1 by 2a. So 2a is 2 root 3 into log of x minus a. So x minus root 3 by x plus root 3. Okay. So this is how you have a complete understanding of this kind of integrations. Let us take one more question. So question is integration of dx by a square root of 2x minus x square. So how to solve this question? Our aim is to see, this is looking like ax square plus bx plus c kind of thing. So if we can convert this in terms of like some x minus a whole square or x minus b whole square, so it will be easy. So can we do that? Just write it down here, 2x minus x square. So can we write it down? We have how much? Let us say I'll write it a minus x common. So x minus 2x whole square, sorry, x square minus 2x. And in this x square minus 2x, what is remaining term that we have? Minus of x square minus 2ab. So 2a into b plus b square I can write. Okay, and then minus 1 we have to do. So we can write it down as minus of x minus 1 whole square minus 1. So I can write it down as 1 minus x minus 1 whole square, because I will take minus inside. So I can write it down as 1 minus x minus 1 whole square. So this particular integration can be written as integration of dx by a square root of 1 minus x minus 1 whole square. So your aim is to make sure how do you change, okay, or how do you simplify this in terms of 1 minus x minus 1 whole square or something like that. Now what would be our next process? Next process is to put this particular term so that we can get rid of this. So what we can do? Put x minus 1 is equal to t. So what we are going to get? Dx is equal to dt. So can we replace this here? So after replacing this, we are going to get dx is equal to dt, that is going to be dt by square root of 1 minus, this is x minus 1 whole square, so that is going to be t square. And we know very easily that integration of 1 minus t square is nothing but sine inverse t. So I can write it down as sine inverse of t plus some constant c. And this t can be replaced again by x minus 1 from here. So from here we are going to put back x minus 1. So we are going to get sine inverse of x minus 1 plus some constant c. So hope you have a complete understanding of how to solve this kind of questions. Let me take one more problem and then we will solve this. So question is fifth one. Integration of dx by x square minus 6x plus 13. Okay, 6x plus 13. So this is looking like in terms of ax square plus bx plus c. So our aim would be to convert this in terms of like squares, right? A plus b whole square. So what we can do, let us put here, we have the term x square minus 6x plus 13. So can we write it down like x square, let's say x square minus 2 times a into b, right? So a is x, into b can be 3, so 2 times 3 times x. So I can write it down 2 into 3 into x. So b can be considered as 3. So I will have to require one more thing, 3 3s are 9. Now what we are going to have, x square minus 6x plus 9, so remaining is 4, so I can write it down plus 4. So 13 can be taken into 9 plus 4. If you don't have 13, then you have to put minus 9 like that, okay? This can be written as x minus 3 whole square plus 2 square. Is that okay? So by putting this understanding, we can simplify our integration in terms of dx by x minus 6x plus 13 can be written as x minus 3 whole square plus 2 square. Now it looks like dx by like some t square plus like a square. So t can be put as x minus 3. So let me change the color here. So x minus 3 is going to be equal to t. So what will be my dx? Dx will be dt. So what will happen? By putting that understanding, we are going to have dt divided by, this will be t square plus 2 square, and we know already that 1 by t square plus 2 square or something like a square, we have the formula 1 by a integration of, let's say, dx by x square plus a square was what? 1 by a tan inverse of x by a. So with this formula we can write it down here. 1 by a, or 1 by a is 2 here, tan inverse of t by 2 plus some constant c. Now we can replace this t with x minus 3. So 1 by 2 times tan inverse of x minus 3 by 2 plus some constant c. So hope you have now very good understanding of how to solve this kind of questions. Let's do one more question. So the question is, and this is going to be very important and very understandable question. So question is integration of dx by square root of 5x square minus 2x. So we have always seen ax square minus bx plus c, something like that, or plus bx plus c. So our aim would be to change this particular like terms in terms of squares, right? So what we can do, can we do this one like integration of dx by, let us say 5 we will take out, so we'll have 1 by square root of 5, and then square root of, here it will come as x square minus 2 by 5x, right? Now this particular term x square minus 2 by 5x, we can convert it in terms of x minus a whole square, something like that. So what we can write here, let us say x square minus 2 times a into b. So I can write it down 2 times 1 by 5 into x. So we have that. Then we need b square. So I can write it down plus 1 by 5 whole square. So 1 by 5 whole square we have extra term. So we have to subtract that so that we can get the original term, right? So minus 1 by 5 whole square. So with this we are going to get this as x minus 1 by 5 whole square. 1 by 5 whole square minus 1 by 5 whole square. So by replacing this, we are going to get our integration as 1 by square root of 5 integration of dx by square root of how much? X minus 1 by 5 square minus 1 by 5 whole square. Okay. So x minus 1 by 5 whole square minus 1 by 5 square that we have got. Now what is the process to solve this? It's very easy. Just put, by putting x minus 1 by 5 is equal to t, we are going to get dx is equal to dt. So this is how we are going to replace this here by 1 by square root of 5 integration of dx is going to be dt divided by square root of, what shall we do here? Tell me. We can replace this x minus 5 whole square very easily. So this is going to be very simple, t square. So it will become t square minus 1 by 5 whole square. Understood? Now you can write it by yourself, a square root of x square minus a square kind of term. So a square minus x square was what? Log of x plus x square minus a square. So we can write it down as 1 by square root of 5 into log of t plus square root of t square minus 1 by 5 square plus some constant c. Okay. Now our aim would be to replace this t with x minus 1 by 5. So we can write it down next, 1 by square root of 5 log of mod of how much it is? X minus 1 by 5 plus square root of this t square minus 1 by 5 square. So see, t square minus 1 by 5 square is nothing but x minus 1 by 5 whole square minus 1 by 5 whole square, right? And this can also be written as this term. So x square minus 2x by 5. So I can write it down as square root of x minus 2x by 5 plus some constant c. So this is going to be your complete solution. So alright, we have seen various questions, like these are all basic questions of particular type integrations. We'll see more questions in our next sessions. Thank you so much.